All right, so section 3, no calculator. You're supposed to do this in 25 minutes. Hopefully you guys have an idea of the pacing from back on Thursday. It's gonna take me almost all class period to do this. So however fast I'm doing it, you have to do this like twice as fast, right? Okay, they do give you formulas for shapes. So 2D shapes, 3D shapes. We got areas, volumes, Pythagorean theorem, relationships, right triangle. So you guys know that's there, you can reference that. Question 1, what are the solutions to the quadratic equation? And oh, look, it's in ax squared plus bx plus c equals 0 form, which is really nice because if it wasn't in that form, then one of the steps would be to get it in that form.
Wait, I thought this was like a physics test. Is this like a math test?
Yeah. So sections 3 and 4 are math. Sections 1 and 2 are reading.
Is this like an SAT practice?
Yeah, SAT.
Okay. I didn't know because I wasn't here when you guys did it.
Okay. Yeah.
I have a 1400 on the SAT right now,
yeah,
so hopefully
that's
I'll
awesome.
do good this time.
Yeah. So yeah, just help everybody short their math section anyway. All right. So there's different ways to do this. You could break out the quadratic formula. You could go that way. I'm going to do a different method. Oh, here, -3x squared minus 3x plus 18 equals 0. I'm going to do a factoring method. Okay. Sometimes there's multiple ways to solve these. One thing I see right away is that each term is divisible by 3. I'm going to pull out a -3. Can I factor out a -3? Is that okay? So I get x squared plus plus x minus 6 is all equal to 0. Now, here, if you were to distribute, don't do what I'm doing in peeking, except to check your answers, make sure you're doing right. If you were to distribute the -3, you guys see -3x squared, -3x, -3 times -6 is positive 18. You guys see how it checks out? Okay. That's just to check your work. Make sure you're on the right track there. All right, here. Update this. Good. Okay. All right, so got a -3, right? And then all this stuff in brackets, I can factor apart. Okay. So you guys remember FOIL, F-O-I-L? Right, so factoring is just the reverse of that. So you can use FOIL to check your answer. Okay. So I need an x and an x, because x times that, so that'll be like first, right? First, outside, inside, left. So the first term is x makes x squared. Okay. I need two numbers that multiply to -6 but add to +1. And what are those two numbers? 3 and -2. A 3 and a -2. Right? Out of here. Right. So okay. So x times x is x squared. -2x plus 3x, that's your outside and inside, adds up to +1x. And then 3 times -2 is -6. Okay, so that checks out, right? Right, now, since I have a bunch of stuff that's now multiplied together and it goes to 0, that means that any part is 0, the whole thing is 0, right? Which means that x could be what from this part? -3. And x could be what from this part? 2. Yeah, so -3 and +2. That looks like option A. Option A. Number 1 is A. Oh, a third way you could solve it is you could just go through the choices one by one and plug them in and see what zeroes out. Number 2, which of the following is an equation of the line M? This looks like y equals mx plus b type, right? Like option A, see where it says x is -2? That would just be a vertical line, so that's no good. Option B, y equals -2, that's a horizontal line, so that's no good. Now, option C and D both have the correct slope. You guys see y equals mx plus b, see it's a up 2 over 1, up 2 over 1, up 2 over 1, right? But then only option C has the y-intercept at -2. So you guys know it has to be option C, right? Alternatively, any coordinate along this line should confirm the equation. For example, how about this point right here? That's 1, 0. If x is 1, y should be 0, right? So let's plug in 1 for x. So 2 times 1 is 2, minus 2 is 0. Yeah, it checks out. That's the only one that works, option C. So 2 is C. Number 3, the circle has area 48 units. Area is 48.
Circles are where I messed up when I did that.
All right. Yeah, show us up here then. So what about this section, just this wedge right here, right? Way I would think of it is how many wedges can fit in the circle? 6. Right. And if you don't see it just by eyeballing it, how many degrees in the whole circle? 360 degrees. What is 360 divided by 60 degrees? 6. There's the way that we formulaically get to 6 wedges.
So is it pi r squared divided by 6?
Well, they already gave you the area, which is true. So pi r squared is 48.
Oh,
And 48 divided by 6 is what? 8. Yeah, so 8 units.
oh, wow, so this isn't even,
This
this
is
is
8.
easier than I expected.
Could be. They could, how do you calculate area of a circle? Pi r squared? Yes. So,
Yeah, I just,
yeah,
I
you never
just,
know exactly.
I don't know. I just didn't even know anything about
Yeah.
circles for some reason. I'd forgotten everything,
Okay.
because I was in like
Yeah.
calculus, and they didn't really talk about circles.
Yeah, well, this much we can. Which of the following is equivalent to the sum of x squared plus x and negative x minus 2? So you can just add like terms, right? Like I only see one x squared, so the answer must have an x squared in it, which by itself could lead you straight to C. Okay, see it. C is the only one that has x squared. But just for completion, positive x plus negative x zeroes out. And then we have this negative 2 tagged on. Yeah, so it's definitely C. X squared minus 2. Is it? Okay, question number 5. Which of the following cannot be an example of a function whose graph on the xy plane has 2 x-intercepts? So we're looking for a counterexample to be the answer. Okay. Let's get some graphs sketched up. Let's go xy axis. Oh, let me zoom out here. Okay, all right. So option A, a function with an absolute value and real zeros. You guys know what absolute values look like? They look like these
Yeah.
V-type shapes, right? That could be described as an absolute value. Okay, so I see 2 zeros right there. Zeros and x-intercepts are synonymous, right? X-intercepts are zeros. Okay, so that's not what we're looking for because that's something that could work. Option B, a cubic polynomial with only real zeros. Well, this could be an example of a cubic polynomial, right? Has a couple of zeros there, a couple of x-intercepts. A quadratic formula with real zeros. Quadratic, that's a parabola, isn't it? A parabola. It's so, okay, so that's the same category. Option D, a quadratic function with no real zeros. That could be a parabola that's floating up there. Okay, so that's what we're looking for, right? That one has no x-intercepts. Okay. So D, number 5 is D. Number 6, square root c minus 1, here, write this down. Square root c minus 1 minus t is equal to 0. If t is equal to 4, then what's the value of c? Oh, well, let's just, so we're solving for c, and t, just put a 4 there, right? You guys have done plenty of algebra in here, so we're going to unbury the c. So I'm going to add the 4 over, square both sides, add 1. Done. That's A. Number 6 is A. You guys got that? 6 is A. Number 7. So x equals y squared. That's like a sideways parabola. And then this other one, well, I see an x and a y that are linearly scaled. So this is some version of a straight line. Xy is a solution to the system of equations, and y is negative. What is the value of x times y? Right. So I've seen a lot of system of equations in these questions. So maybe one thing we could do is,
Isn't that, wait,
yeah, everywhere you see an x just replaced with y squared, you can do substitution, right?
wait, if x equals y squared, then the value of xy is just x times times the square root of x, isn't it?
X,
Times the square root of x.
oh, yeah, that is true. Yeah, that's another way you could do that. Yeah, x times the square root of x, which I guess that would narrow it down. Like there could be lots of answers, but there's probably only like, some of these that would work, right?
Yeah, because
Well, that would narrow it down to what, B or C, I think. Here's something I don't know. Here, let's try that. So I'm going to do a substitution method that also plays off the second equation. So 6 times y squared, instead of actually saying y squared, got plus 9 equals, and then here, I'll go ahead and distribute this. Negative 3 times 2y is negative 6y, and negative 3 times negative 3 is positive 9. Can that be like that? Okay, so did a couple steps here, substitution and distribution. Okay, so can you just bump those 9s? Subtract 9 from both sides. Okay, I'm going to add the 6y over, so I'll get this 6y squared is already there. I'm going to add this 6y over here and set this to 0.
divide out the sixes, right?
Yeah, I'm going to factor out 6y, y plus 1 is equal to 0. Okay, it's just okay. So if you do this method, then y could be what from here? 0, and y could be what from here? -1. Okay. Now we still got a couple more things to do, because they said we're specifically interested in y is strictly less than 0. So y has to be negative, which means we care about this one specifically. Okay. And the other thing is they really ask for what is x times y. So let's go back to x is equal to y squared. If you plug in a -1 right there, then x must be equal to what?
1, and so it's
One.
negative 1.
Ah, yeah, so xy equals, right, this 1 times this -1, which is -1.
Which is either B or C.
Well, in this case, B. Yeah, so 7 is B. Okay, you guys got 7B? 7 is B. Number 8. Richard either walks or rides his bike everywhere he goes. When he walks, he burns 50 calories per mile. When he rides his bike, he burns 25 calories per mile. Side note here, notice we're doing on a per distance scale rather than a per time scale. Just want to think about it. Richard can travel no more than 15 miles per day, which sounds like a constraint. You can only go up to that far. But he wants to burn at least 500 calories per day. Ooh, so now he's got this conundrum, right? Like if he makes the wrong decision, like maybe he rides the bike too much, he's out of luck. Which of the following systems of inequalities represents the situation in terms of W and B? W is number of miles walked, B is number of miles riding his bike. Right? So they don't even want you to solve this exactly. They just want to see what's the setup. Right? Can you translate that story into math? So system of equations looks like the first equation of each of these options has to do with calories burned, right? Number of calories per mile times number of miles, whether walked or biked. Okay, yeah, that would be number of calories. So is it okay if he burns 600 calories? Yeah. Is it okay if he only burns 400 calories? Because, okay, so he wants to burn 500 or more. So look at option A. See where it says, if you add up all the calories he's burning, is less than or equal to 500? Is that okay? That's the wrong way, isn't it? So we're going to scratch out option A just because that inequality is the wrong direction.
And option B, D. Not
Yeah, you're right. Option D for the same reason. So A and D are gone. Boom, boom. I mean, yeah, at a glance, you guys can see all these look really similar, right? So we're looking for little details like that. Like that's gone, that's gone. So we're narrowed it down to these two. Now let's go over to the number of miles traveled. Remember, now that's constrained. He can only go up to 50 miles per day.
So it's gonna be C.
Hold on.
No, so it's gonna be B.
You're right. It is B. Yes,
C.
because walking plus biking
I can't believe
can
it.
only go up to 50 miles, right? So, right, you guys good? Number 8 is B. Number 8 is B. 8 is B.
I can't believe I said that.
Yeah. Electric practice. We got this for electric practice. There you go. Number 9, Rankine scale. Alternate scale for measuring temperature, where temperature is in Rankine. The conversion from Celsius to Rankine is given by, all right, Rankine is a function of Celsius. So that's how you read that. Is 1.8 times the temperature in Celsius plus 491. Ooh, that looks kind of similar to some stuff we've done recently here. Which of the following statements is the best interpretation of the number 491 in this context? Option A, the increase in degrees Rankine that corresponds to a 1 degree Celsius increase in temperature. Ooh, because what number describes option A? 1.8. Because every degree increase in Celsius, you scale Rankine by 1.8 times that. So if it said 1.8 here, the answer would have been A, but that's not what they're asking. The increase in degrees Rankine that corresponds to a 1.8 degree Celsius rise in temperature. That's some kind of weird reciprocal that, okay, that's even more off the beat. That's not what we're looking for. At all, right? C, the temperature in Rankine at 1.8 degrees Celsius. Okay, if you plug in 1.8 degrees Celsius here, 1.8 times 1.8 plus 0.9, okay, that's not what, that's totally wrong. Option D, the temperature in degrees Rankine at 0 degrees Celsius. Ooh, see, if you plug in 0 degrees Celsius, 0 times 1.8 is still 0, plus 491 is 491. That is what we're looking for. D. Yeah, number 9 is D. You guys got that? D for 9. Also, if they said the freezing or melting point of water, that would have been a physics crossover. That would work too, right? Number 10. Okay. Which of the following is equivalent to 4 to the power of 5 over 6? Now, having seen enough SATs over the years, SAT cares about that you know how to work with exponents, like exponent math. I thought this was a really tricky question. So here, I'm not going to give you probably the best explanation, but I'll give you an explanation that will get you to the answer. Okay. So here, 4 to the power of A plus B. Now, I know it looks something like that, but I'm going to lead it towards this. Okay. Is that the same thing as 4 to the A times 4 to the B? Right? Wouldn't that be true? Okay. So if you have exponents that are added together. This thing's like multiplying the bases. Okay. Oh yeah.
Can I use the bathroom?
Okay.
Thank you.
Okay. So hang on to this idea because we're gonna have to use this at some point. Now they gave us 4 to the 5 over 6. Okay. And sometimes it helps to glance at the answer choices too. You can kind of figure out where we're headed with this. Right. So let's look at a pie chart. In fact, I know a few questions ago they were looking at the 6 of a circle. So let's see a whole like trivial pursuit wheel going on right here. 5, 6. There's 5, 6, right? That's 5, 6. Okay. Hey, is that the same thing as 1/2 plus 1/3? Right? Isn't that 5, 6 is half plus a third? Is that okay? Same thing? Right? Here, maybe we'll do this a little better. Right. 1/2 times 3 over 3 plus 1/3 times 2 over 2. Get like a common denominator. That would have to be 5, 6, wouldn't it? Like I said. Okay, so we're going to take 4 to the power of 1/2 plus a third, right? Which puts it back in the context that I started at. Right? So it's the same thing as 4 to the power of 1/2 times 4 to the power of a third. Right? Get that? Right. And what is this right here? The square root of 4, which is 2. Yeah, so this is just 2. Like a 1/2 power is the square root, right? And what's another way to say a 1/3 power? The cube root. Right. Now it turns out that this is the answer they're looking for. 2 times the cube root of 4, which is option A. So 10 is A. Right, get that? Okay. Again, that's one of the trickier questions that I've seen them ask with exponents, but you do have to know things like this. So make sure you know exponent math going into Wednesday. Okay, you guys work with exponents. Okay. Might want to Google or YouTube a quick tutorial on that if you need a refresher on that exponent math. Right. If x squared plus y squared equals c, which looks some version of a circle, probably, right? A circle, and negative xy equals b, which is some kind of inverse type relationship, which is following is equal to c plus 2b. Okay, well, yeah, never mind all that graph stuff I said. Let's just plug and chug with this guy. C plus 2b. C plus 2b. Well, c is x squared plus y squared. B is negative xy. Okay. Oh, this is another one where it might help to glance at the answer choices. It looks like something quantity squared. Ooh, I wonder if I could shuffle this around and make it look like that. Could I do x squared minus 2xy plus y squared? That's the same thing, right? Okay. Oh, and then I'll like reverse FOIL. I'm going to write FOIL even though I'm doing it backwards. Maybe FOIL could check my answer. Okay. So first, I need an x and an x so I can get x squared. I need something to do with a y and a y and jump at the last so I can get the y squared, right? And then negative 2xy. Hey, should I do minus and minus? Right. First, outside, inside. Last, right? That checks out, right? Is that the same thing as x minus y quantity squared? Right. Which is option C. 11 is C. Okay, you guys get that? 11C. What if you saw this? What if you did y squared minus 2xy plus x squared, and you ended up doing y minus x quantity squared? Is that the same thing? That is the same thing. Yeah, because now the inside is one is the negative of the other, but then if you square it, it's the same thing. Yeah, so that would have also worked if they'd offered that as an option. All right, that's it. Okay, number 12. The volume of a cone is 12 cubic millimeters. What is the volume of a cone with a third of the radius but triple the height? This is where, here, remember they gave you the formula for a cone, right? On the front. So let's look at this. Cone, right, got some radial size r, got some height h, right? So the volume of a cone is, actually the volume of anything comes to a point. Could be cone, could be a pyramid, is you always take the base, which in this case is pi r squared, isn't it? Pi r squared is that base right there. Multiply by the height, make it three-dimensional. Now, if you stopped right there, that would be a cylinder, right? So that's the volume of a cylinder, right? This base times this height. Okay. But if it comes to a point, you always multiply by a third. Okay. Okay. They give it to you anyway, but just to review. Okay. And they said that this is 12 cubic millimeters. Right, be like that. Okay. Then we're gonna do is we're gonna have a third of the radius, but 3 times the height. So we're gonna make a tall, skinny guy going on right here. So it's 3 times the height, but a third of the radius. And say, what's the volume of that guy? Now, this is where actually it's really good that you guys are in physics because you guys seen this a lot of stuff like this. Remember, like questions like if a car is driving 3 times as fast, it's like 9 times the braking distance because there's like a squared relationship. Right? We're gonna navigate sort of like that. So the volume in the new cone is, well, it's some proportion of the old cone, right? It's like a proportional type relationship, right? Kind of analogous to like what's the braking distance of the car, okay? So we're scaling up the height by a factor of 3. So we have to throw a factor of 3 in here, right? I'm doing kind of a shortcut method, but you guys seen this so many times in physics, okay? If you only did that, you would have 3 times the volume. If you left the base, that area of the circle the same, you just did 3 times as tall, it would be 3 times the volume, right? But there's also 1/3 factor on the R, right? So we're going to do 1/3 for the R, but don't forget that the R is being squared, which gives you a base that's only 1/9 of the original circle. Okay? So guys, what is a third squared times 3? What is all this? That is a third, isn't it? So the new volume ends up being a third of the old volume. There's a more proper way to do this with like system of equations, but that's what it comes out to at the end of the day. And the old volume was 12 cubic millimeters. So what is a third of 12? 4 cubic millimeters, right? Which is option B. 12 is B. Okay, guys, give that. 12 is B. Yep. All right, 13. Marcy spends an average $42 on coffee each month. She buys special pods of coffee that cost $7 each. Recently, Marcy decided she wanted to reduce the amount of coffee she drinks per month by 9 cups. So she's reducing 9 cups per month. Assuming pods can brew 4 cups of coffee at a time, so 1 pod is equivalent to 4 cups. What equation can she use to determine how many dollars D she will save each month? All right, I think this was probably the trickiest question. Well, this one, the exponent question, were real tricky. So I want you guys to, actually, I don't know exactly why they got or how they led to the answer they got. I'll get you guys there. I'll get you guys my own way. I would just use dimensional analysis to get the exact answer and then work it from there. So dimensional analysis, I'm going to set up some railroad tracks. Railroad tracks. Okay. And here's the detailed notice too. That $42 she was spending per month is completely irrelevant to what they're asking about. They could have changed this to $100 per month and it wouldn't change anything because this has to do with like her reducing the amount of coffee by some amount, and then it's all proportions based on that, right? So you can see a bunch of proportions, right? So as long as she doesn't go to $0, okay. We want to reduce by 9 cups per month, right? So that's like the target value, right? 9 cups per month, right? And I know that there are 4 cups and 1 pod, right? You guys remember doing lots of stuff like this in this class, right? 4 cups in a pod. You guys see cups is set up to cancel out, right? And every 1 pod costs $7, right? And this is set up in such a way that I'm going to get dollars per month that she's going to save. And they say that that is equal to D. D equals that right there. Right? So I would just say 9 times 7 is 63 divided by 4. Whatever 63 over 4 is the exact answer. That's exactly how much she's saving per month. But they're trying to do this thing where they say, well, what equation could you set up that would lead to that? So we have to take this answer and sort of backtrack to something that looks like one of their answer choices. I'm going to say D equals, I got a 9, I got a 7, all divided by a 4, right? So can we somehow rearrange this to look like one of their answer choices? And the one that ends up working is if you cross multiply the 4 and divide the 7, right? That's how they went. Yeah. So cross multiply the 4, divide the 7 down, got the D up here, D's in the numerator. That's all equal to 9. Okay. Option A looks exactly like that. So the answer is A. Number 13 is A. Okay, you guys good? 13 is A. Okay. Yeah, so there might be like backdoor or roundabout ways you might have to do this. You might have to solve for D exactly and then see which of these would correspond to that. Right. Okay. Number 14, at a juice bar, S servings of banana smoothie are made by adding B bananas to the blender. If S equals B minus 4, ooh, right? How many additional servings of banana smoothie can be made with each additional banana. So this sounds like an incremental type change, right? Maybe if this was a line, right? Could you guys imagine if number of bananas is the x-axis and number of servings is the y-axis, right? Bananas, servings. This would be like a linear relationship, wouldn't it? Right? You guys see there's a 1-1 relationship between the number of bananas and the number of smoothies, right? Like the way to imagine this is maybe there's some smoothie maker, and for it to even function to turn on, it has to have at least like 4 or 5 bananas, otherwise it just won't even turn on, right? But once you have enough bananas, every additional banana you add, you're getting 1 more smoothie, right? And you don't quite say it because it's just like so this line, right? So there's an applied 1 right here, coefficient of 1 in front of the B for bananas, right? You can plug in some numbers and test it out. Like for example, what if you put in 10 bananas? 10 minus 4 is 6 servings. What if you put in an 11th banana? That's 1 more banana, right? 11 minus 4 is 7. So go from 6 to 7 servings. You see if you increase the bananas by 1, the servings goes up by 1. So the answer is 1. The answer is A. 14 is A. Guys got that? 14 is A. 15. G, oh yeah. G of x is 2 minus 3 to the power of x. Now that is an exponential equation, which we almost never do in here. I may have mentioned that like briefly once, exponentials. So G of x is defined by that equation, which is the following is a graph of negative G of x. Ooh, that was one of those details we had to get, right? They made it negative. So I could say y equals negative G of x. That's like negative 2 plus 3 to the power of x, right? Isn't that actually what we're graphing? Or I really prefer it this way. Y equals 3 to the power of x, then minus 2. Okay, that's an exponential. You haven't really seen those in this class. You haven't run across this in any of the labs that we've done, right? We might hit an exponential decay like in the future or kind of use that, but okay, so we need to graph that. Hopefully you guys have been in a math class, you remember how to graph this. But if not, then what you can do is you can throw some points on the board and graph it from there. For example, what if x is 0? Guess what is 3 to the power of 0? 1. 1. So if x is 0, and then 1 minus 2 is negative 1, right? So if x is 0, y ends up being negative 1, right? Because 1 minus 2 is negative 1. What if x is 1? What's 3 to the power of 1 minus 2? 1. So if x is 1, y is also 1, right? Let's get crazy. What if x is 10? 3 to the power, isn't that just a crazy big number? So this is going to take off super big, super fast, like way faster than a parabola. It's not even going to be close, right? So these exponentials take off, whoo, crazy. Okay. Let's go the other way. What if you plug in a negative number? Let's go crazy with that too, like negative 10. 3 to the negative 10. Is that the same thing as 1 over 3 to the 10? Right? That's what negative exponents are, right? They're fractions. They're not negative numbers. Negative exponents just create fractions. Okay? And if you buy a lottery ticket one day and you have like a 1 in 20 million chance of winning, you basically have a what chance of winning? 0. Right? Now tag on this negative 2. That's gonna develop into a what property of this graph? Horizontal asymptote. Yep. Right. So hopefully you remember how the graph was from math class, but if not, we just reconstructed it. Here's an exponential, right? Which looks exactly like option D. Option D. You guys see option D? Okay, guys good? Right. Okay. Now we're done with multiple choice, and you guys are gonna start bubbling in. So you guys see how this works? You're gonna write some number and then like bubble in the bubbles. And some of these are decimals or fractions. So you get some slashes and some decimal points, which might have to use. Okay. Number 16. 1/3 n minus n. Oh, sorry, 1/3 5n minus n equals 31 on 3, and n equals 3m. System of equations has solution mn. What is the value of m? Well, I should just take this n equals 3m and substitute it right there. Okay. So let's do 1/3 of 5m minus 3m is equal to 31 and 3. Right, is that okay? Oh, can I just scratch out this 3? Multiply both sides by 3, right? Okay, 5m minus 3m is 2m is 31, right? Okay, so m is 31 over 2. Okay. Remember, this is no calculator. They are accepting 2 answers for this. You can write 31/3 or sorry, 2, 31/2. Then you bubble in 3, 1/2. Or you can do 15.5. You have to bubble in the decimal. Okay. So they'll take either one of those. Right? You guys good there? Okay. Number 17. Asaf plans to start working out at a gym. The gym membership costs $50 per month, and he will also have to pay a $30 one-time registration fee. Right? Already, I'm thinking this is going to be y equals mx plus b. Can you guys see it? Right? This m, this x, this b. Right? It's all there. Right? Asaf wants to spend no more than $555 for everything altogether. So that's his budget constraint. If gym memberships are only available for a whole number of months, so no decimals, whole number, what is the maximum number of months that he can attend gym membership? Y equals mx plus b. Right. Let's translate that story into equation. So $50 per month. There's $50 per month times number of months. I'll call x, and we're solving for x. Right. Okay. There was a one-time registration fee, so we're going to tag that on. Just add that. Okay. And this can go up to $550. Okay, guys. And really, if I want to be strictly correct, I would say this, right? Make 550 greater than or equal to.
It's 555.
Oh, thank you.
Yeah.
Oops. Yeah. Yeah, thanks, man. Yeah, 555. All right. So, yeah, good catch. And so, we got subtract 30. That's 525 greater than or equal to 50x. Right. And then divide both sides by 50. Right. Now, if you can do that, awesome. Remember, you have no calculator for this section. Here's what I would do. I might chunk this down. This is 50 equal to 5 times 10. So could you just divide by 10 and divide by 5 or vice versa? Right. So I'll do that. Just show way of thinking. 52.5 is greater than or equal to 5x. Right. How many times can 5 fit into 52? Up to 10. You got 10 and change, right? So after he buys 10 months of membership, then he'll have a little bit of money left over, but not enough for the 11th month. So they want you to bubble 10. So you had to write 10 months. Okay. Because that's a whole number. Okay. Number 18, these intersecting lines. What's the value of this angle right here? C. So, right, so we got 34 degrees here. We got 97 degrees here. We got C degrees here. Okay. And so two things you have to know about geometry to get this. One is, what do these two angles add up to? 180 degrees. Like a straight line is 180 degrees, right? Actually, let's knock that out right here. So 180 minus 97 is that 83, I think. So this has to be 83 degrees. Okay. The other thing you have to know to get this is for a flat triangle, what do all three angles add up to? Also 180. So let's add these two guys together. 34 and 83. 117. Right. And then if you do 180 minus that 117, 710, 3, 63 degrees. That makes it 63 degrees, doesn't it? Right. Okay. Right. And then we're back to that first rule where these two guys must add up to 180. So, but you know what? Here, I mean, I could do that. 180 minus 63, but it's something that you kind of already have because 180 minus 117 is 63. Therefore, what's 180 minus 63? 117, which is the answer. Okay, 117 degrees. Right. Right, you guys got it? Right, so the answer is 117. Now there is a shortcut to this. Whatever this angle is, what we're looking for, C, is always the sum of these two guys right here. Right, you guys got it too? Right, you guys got that shortcut? Right, you guys got it? Number 19. 9 times s minus 2 plus 3 times s plus 2 is 7s. What's the value of s? Okay. I'm going to change s to x because I don't want to mess up my S's and 5s. Right. All I have to do is solve it and write the numerical answer anyway. So we're just going to solve for x. Right? Think of it like that, right? So first step, I'm going to distribute. So it'll be 9x minus 18 plus 3x plus 6 is 7x. True? Just like that? That's good. Okay, and then pull the x's together, I got 12x, and then the constants, I got minus 12. That's 7x. Okay. Subtract this 7x over, add this 12 over. That'd be 5x over here, and I got 12 over here. Right? We're good. Okay. Divide both sides by 5. 12 over 5. All right. So they're accepting 2 answers for this. You could do 12/5. They'll take that. They'll also take, let's see, 5 and 5 is 10, and there's 2 over 5 is 0.4. I'll take either one of those.
Oh,
Yeah.
all
Okay, you guys got that? Good. Okay, number 20. We got this fraction minus this fraction. They're saying is equivalent to this fraction, where x is a positive constant and c does not equal to 3/2. What's the value of x? Side note here, why can c not be equal to 3/2? Right, then you'd be divided by 0. So on a graph, that would either be an asymptote or a hole, right? Could be, right? So that's just a side note though. Okay, let's just solve for x. So we got 4c plus 1 on 2c minus 3 quantity squared minus 2 over 2c minus 3. Oh, okay, just that. I'm going to leave a space and then equals x over 2c minus 3 quantity squared. Right? Is that true? Right. Now, if you want to add or subtract fractions, you have to have a what? Common denominator. Yeah. Can I? Ooh, it's almost set up that way. It wants to be 2c minus 3 quantity squared, doesn't it? Yeah. Can I take this middle fraction and square it and work with it then? Ah, so you guys shaking your head. You're right. Right. You cannot do that. Because if you did, you'd be changing it. You'd be manipulating it. It would be something else. What do I have to do instead? Exactly. Multiply top and bottom by 2c minus 3. And the reason that works is because that fraction right there is actually equal to what? 1. So you're not actually changing anything. You're just manipulating it so that it matches. Okay. Okay, so here we got 4c plus 1. We got distribute this 2. I've got minus 4c. And ooh, careful about this. Minus and a minus. Is that plus 6? Right? And I got an x over here. And they all have the same denominator. So scratch, scratch, scratch. Now we're okay, right? Right, it's the same denominator. You can just multiply it, cancel out. Okay. Ooh, what happens to the 4c and 4c? This way, which is really good news because we're solving for x, and we need some kind of numerical answer. So this is a hint that we're probably on the right track. I mean, that had to happen. So you can bubble in the correct answer. 7. The answer is 7. Okay, you guys got 7? All right, are we good? All right, let's get started on section 4. All right, so remember everything we just did this class period is supposed to do in 25 minutes. So like twice as fast as I was doing it. Right. This next section you get 55 minutes. Right. And you're allowed to use a calculator. Right. But it's a lot of the same skills, just for calculators particularly handy. Sam's special hot chocolate recipe calls for 4.5 ounces of cream for every serving of hot chocolate. How many cups of cream are needed to make 24 servings of hot chocolate?
Oh, okay. That's
1 cup is 8 ounces.
good.
right.
That's tell you.
Yeah. I'm going to solve this with dimensional analysis. Now, the previous section, section 3, they might have said something like, what equation could solve this? And then you have to figure out that way. I'm just going to go straight dimensional analysis. So, set my railroad tracks. So the target question is 24 servings. 24 servings. I know that every 1 serving, you need 4.5 ounces. And every 8 ounces, you're saying is 1 cup. Right? Isn't that exactly how you set that up? Servings, ounces. This will tell you exactly how many cups you need. So multiply across the top, 24 by 4.5, divide by 8 on the bottom. I'm looking at 13.5 cups. Okay. Which is option D. Right, you guys got D for number 1? Number 1's D. Okay. All right, you guys good there? Okay, we got about a minute class left, and that's as far as I've been able to get my other class today. So, right, you guys got any questions so far? All right, so tomorrow we'll do as much of that as we can, and yeah, go from there. On board.